Yeah. Good afternoon, students. I'm happy to meet you again this afternoon on this platform. The course we know is Technical Mechanics, TMT 120. And right from the beginning of this course, I've tried to introduce you to mechanics in a very simple way so that you people will understand it. But as I told you before, this course mechanics is not a strange course to anybody that did science in the secondary school. Because secondary school physics, basically, we know that it's broadly divided into mechanics, very large, electricity, very large, electrolysis, very large, and other aspects. Is it clear? So, the nuclear physics, among other aspects. So, the mechanics aspects is what we are building on in this course. Is it clear? So, I'm going to revise what we did on Tuesday. We are here on Tuesday, 12 noon, and we cover a lot of grounds. Today we are going to build on what we started on Tuesday. Now, by now, there is no student that cannot define that don't know what mechanics is. I said that mechanics is a branch of physics, or you can say a branch of science that deals with bodies, rigid bodies, in motion, and at rest. That is, mechanics is a branch of physics that describe and predict the conditions of rest or motion of bodies and particles subject to the action of force or forces. We can also define mechanics as the science of the motion of bodies. When I say bodies, we are talking of celestial bodies. We are talking of bodies in the physical bodies, like the phone you are holding, like the laptop you are using, like the chair you are sitting on, like the stones you see outside, the pebbles you see everywhere. Those are all rigid bodies. So that is solid mechanics. Now, that last Tuesday, which is just 48 hours ago, barely 48 hours ago, we were talking about contact forces. In contact forces, we have contact forces in rigid bodies, in solids. We call it solids. So that is why we were talking about friction. And I told you that friction is the force that opposes motion between two bodies in contact. That is, frictional force refers to the force generated by two surfaces that contact and slide against each other. And I said that the forces are mainly affected by the surface texture and quality of the force. Quality of the force requiring that is acting on them, or that is joining them together. And we also talk about the angle and position of the frictional force. And that the angle and position of the object also affect the volume of frictional force. And I gave you a formula, and from there I was talking about mechanical advantage. That is the frictional forces in engines. I made reference to motor cars. I said that motor cars for automobiles, they spend 1/4 of their energy, that is 1/4 of their energy, trying to overcome frictional force first before they start moving. Is it clear? Or even while they are moving, is it clear to you? And that is a disadvantage to automobiles, but that frictional force is also an advantage to automobiles, to cars, to moving bodies, even aircraft, tricycles, what have you that moves on the road, that even trains, that frictional force is advantageous to them, in that the tires, the hold between the tire of a vehicle and the road is frictional force that make them to be able to move. Is it clear? We talk about that. And we're now talking about factors that affect frictional forces. I measure surface tension, I measure angle of position of the object, etc. That is by way of revision. We now talk about normal force. We talk about normal force. We did a calculation, and I gave you your assignment for that day. So today, we are moving higher. Today, basically, our topic for today is fluid at rest and in motion. Please write it down. Fluid at rest and in motion. If you got it right, I have to introduce this topic. It is a follow-up to that topic where we dealt with on Tuesday that I just summarized to you. When we say fluid at rest, and fluid in motion, I have to define what is fluid. Fluid simply means liquids and gases. Is it clear? Fluids, that is Fluids. Fluids, that is plural, refers to liquids and gases. I believe it's clear to you. So what are we talking about? Fluid in motion and at rest and in motion. What it means is that aside frictional forces that we experience in solids, that like when you are walking on a staircase, like when you are walking on a third road or on an earth road, or like when the vehicle is traveling on an expressway or on a local way, there are frictional forces in liquids and in gases. I believe you got it right. I said apart from frictional forces that we experience in solids, which I explained in detail last Tuesday, today we are going to be talking about fluid at rest and in motion. And that when we are talking about fluid at rest and in motion, we are talking about frictional forces in gases and in liquids. Now, we all know the meaning of gas and we all know the meaning of liquids. We know the chemical properties of liquids and we know the chemical properties of gases. We know the difference between gases and we know the difference between liquids. We know that gases are highly compressible, while liquids are not as compressible as gases. We also know that gases, they expand in the container that is holding them, while liquids only expand while temperature increases. Is it clear to you? So that is the bulk of that is the summary of what we are going to do today. Now everything is going to be practicalized. This topic of fluid at rest and emotion, I'm going to practicalize everything, and you will see it in everyday life. Now I'm going to come by saying all living creatures live inside fluid. If I explain it, you are going to understand what I mean by that. All living creatures, whether it's a plant, whether it's an animal, whether they are high animals like we, whether they are smaller animals like insects, like rodents, whatever animal that you have in the forest, in the wild, or plants, they live inside a fluid. Is it clear to you? As you are sitting down in your sitting room, as you are in your living room now, or I don't know where you are taking this class, wherever you are now, you are sitting inside a fluid. What do I mean? You are surrounded by air. Is it clear? So while you are walking up and down, you are taking your evening stroll, or you are sitting in a classroom, or you are driving, wherever you find yourself in nature, you are covered in a fluid. What is that fluid? Oxygen and other gases that makes up the air. We know that air is a mixture of gases: nitrogen, oxygen, carbon dioxide, water vapor, etc. So while I am sitting down here in my living room now taking this online class, I am sitting in a fluid. I'm covered in a fluid, and that fluid is oxygen. Is it clear to you? So animals and humans inhabiting lands are immersed in a sea of gaseous fluid. The air which provides them with oxygen needed for their biological existence. That's what I've explained. Marine life is sustained in the second type of fluid. Now, we are not marine organisms, human beings. By now, in your biology, in your basic biology, you will know that living things have different habitats. There are living things that inhabit the marine environment, and there are living things that inhabit the land environment. Is it clear? There are also living things that inhabit trees, although all those ones we take all of them as land. So basically, living things are either living on land or they are living in a body of water. No matter the size of the water, they are there. So we on land, that our features, our respiratory organs have been fitted to survive on land. We are living in a sea of fluid, that is gases. Then marine organisms that are able to survive in water, are also covered in a sea of fluid, that is water. But mind you, oxygen needs to be dissolved in the water for the organism to be able to live. That is a different ball game. You see, that one is biology. We are in a physics class here. We are in a mechanics and a physics class here. So that is that. So what I'm trying to let you know by way of introduction is that marine organisms are living in a sea of fluid, which is liquid. Water is a liquid. And land organisms, of which human beings are part of it, are also living in a sea of fluid, and that fluid is oxygen, that is gas. Is it clear to you? So that is that. Now, the difference between the two types of fluids, that is the difference between gases and liquids. So in this case now, oxygen and water, is that gases are compressible while liquid are not compressible, are hardly, very difficult to compress them. They are not easily compressible. You know what I mean by compressibility of gas? You can easily compress a gas in a container. That is why you can transport a large volume of a gas in a small container, because gases are compressible. When you subject them to ambient temperature and controlled temperature and pressures, gases becomes highly compressible. Is it clear to you? That is the difference between liquids and gases as fluids. Now, the common property that are shared by all fluids, whether we are dealing with gases or we are dealing with liquids, is that they cannot sustain shear forces. The common property, please be writing. I'm going to come slowly. If I'm not able to finish the course today, I'm going to use it to give you an assignment. So let me take it slowly so that everybody that is listening will understand. See, what I'm telling you is that fluids are made up of gases and liquids. And I don't need to start telling you what gases are. You know in your chemistry class, SS1 chemistry, even GSS3 integrated science. And you know what liquids are. If the most common liquid is water. You saw water is referred to as a universal solvent. Is it clear? Because it's everywhere and it dissolves many things. So now I'll give you the difference between liquid and gas. That gases are easily compressible, they are highly compressible, while liquids are not compressible, if at all, very difficult. Is it clear? Then one similarity between liquids and gases is that none of them can support shear forces, which solid can. Is it clear? What do we mean by that? Now you can put your I was telling you about frictional force, that when you put your laptop on the table, or when you stand on the table will support you. You will not fall. But go and stand on top of water, or go and stand in your balcony and jump from there. You cannot stand on air. Neither can you stand on a liquid. Is it clear? Naturally, you know this. What I'm telling you now. You are not Jesus Christ that walked on water. So that was just a supernatural event. So, but in science, we are talking of science here now, that liquids and gases, they don't support shear forces. That is that. So I quickly move to what is called surface tension. So now you are going to write down a subtopic that is surface tension. So write surface tension. Yes. I'm going to give you the points, then I'm going to explain it. Now, when we talk of surface tension, what we mean is that if a particle, for example, a plate, a plastic plate, you put it in a liquid, say in a pond, maybe a swimming pool, or you have a basin of water. You now put a plastic spoon, or a plastic takeaway, all these takeaway packs, you know them. You put it inside that plate, that basin of water. You see that the plastic will not sink. Is it clear to you? It's going to remain on top of that water, but there's going to be tension between the base of the plastic and the top of the water. There's going to be tension there. Is it clear to you? That is, in a nutshell, what we mean by surface tension. It is that surface tension that makes the plastic to remain without sinking. Now, the surface of a liquid behaves as if it were covered by an elastic skin. Is it clear? The surface of a liquid behaves as if it were covered by an elastic skin. Full stop. The surface, therefore, appears to be under some forces or tension. You see it? The surface, if you put water in a plate now, a big basin, the the water is going to be under tension there inside that basin. So which means the water in a pond, the water in the river, even the water in the high sea, they are out there under tension. That tension is called surface tension. Is it clear to you? The tensional forces acting parallel to the surface of the liquid. Please write down. The tensional forces acting parallel to the surface of the liquid is called surface tension. I come again. The tensional forces acting parallel. You know what is mean by parallel? That is into lines that never meet. Two straight lines up and down. To the surface of the liquid is called surface tension. Now, another point here. This surface tension arises due to the strong intermolecular forces holding the liquid molecules at the surface together. I come again. The surface tension is due to strong intermolecular forces. You know there are intermolecular forces that hold water together. Every substance, whether liquid or gas, or whether what is it called, whether solid, they have molecules. They are made of molecules, and those molecules are held together by strong forces. There are some substances that have weak forces of that are holding them together. They call them van der Waals forces. So that is strong, very weak forces of attraction that exist among the molecules of a liquid or of a substance. Basically, weak substances. Now, the reason why there is surface tension in a liquid is because there are intermolecular forces that are holding the liquid molecules at the surface together. Is it clear? So now we take a practical example. Now, pour water in a basin. You pour water in a basin and you put a steel needle. You know what it's called needle? That needle that they use in a gently, you put it gently on top of the water in a basin. The needle will not sink. This experiment we have done before in physics in the secondary school. In SS1, this is SS1 course. On top of it, the needle will stay on top of the water without sinking. Mind you, the needle is going to be subject to the force of gravity. Force of gravity also acts inside in fluid, just as they act in solids. So it's going to be subject to gravity. Then there's going to be force at the surface of the water between the needle and the surface of the water. There's going to be a tensional force between the needle and the surface of the water. Is it clear to you? Now, that needle is going to remain there. It's not going to sink due to surface tension. Is it clear to you? So that steel needle is supported by surface tension. That's why it's not going to sink. So that is one practical example of surface tension. Now, I'm going to give you 2 points in surface tension and 2 formulas. Now, the coefficient of surface tension is represented by capital letter T. The coefficient of surface tension is T, capital letter T, is defined as the force in Newton acting on a meter length drawn on the surface of the fluid. Is it clear? I come again. The coefficient of surface tension in bracket capital T is defined as the force in Newton acting on a meter. That is the distance now. The force is acting on a meter. This they are taking as 1 Newton. 1 Newton. That we assume that the force is 1 Newton acting on 1 meter at the surface. Is it clear? So I give you the definition of coefficient of surface tension finally as the coefficient of surface tension T is defined as the force in Newton acting on a meter length drawn on the surface. Mathematically, surface tension T equals capital F over L, where F is the force in Newton and L is the length in meter. I come again. Mathematically, coefficient of surface tension capital T equals F over divided by L. I take it again. Surface tension T, capital T, equals F over L. That is force in Newton over length in meter. That is coefficient of surface tension. Now, the second point, the surface tension T is defined as the ratio of the tangential force F in the surface to the length D along which the force acts. It's the same thing. Is it clear to you? We are dealing with the same thing here. We are still talking about force. We are still talking about length. But this one, we are talking about the tangential force. So in this case, mathematically, T is going to be F over D. Is the same thing. The formula I gave to you in this first example is the same thing I'm giving to you here, but in a different way. Is it clear? Because of the tangential force. The tangential force is now talking about the direction in which the force is acting. Please take note of all these things. These are things that are supposed to be practicalized. Is it clear to you? But for some of you that went to schools where they do practical, secondary school where they do practical, this thing you would have done it in physics laboratory. It's very simple. Now, for example, I'm going to give you another example that will make you understand what is surface tension. You know what is called cork? You know what is called cork? That is the cover of a bottle of wine. The cover of a bottle of wine is called cork. You have some cork that are made of woody material, very light. Drop it on top of water, maybe in a basin. If you put it on top of water, you will see that the cork will not sink. It's going to stay at the top. Even the cork of wine, or not only wine now, even though you want to experiment it with the cover of drinks, that is carbonated drinks or beer, that cover of beer, to put it in a basin of water, you will see that the cork is not going to sink. It is not going to sink because there is what is called surface tension between the surface of the cork or the bottom of the cork or the side of the cork that is resting on the water and the top of the water or the surface of the water. There is a tensional force that is acting between the two bodies. That is the water and the material that you have dropped on top of it. Is it clear? So now I'm telling you that there is a force called tangential force that acts per unit length or distance. So T equals F over D, where D is distance in meter. So that is that takes us to the next aspect of this of training. Now, now another point is that surface tension is a force. You can take this one as your definition, please, in case you are asked in the exam. Surface tension is a force per unit length. Per unit length. Just take it like that. This is the simple definition for surface tension. Surface tension is a force acting per unit length. Please add that acting to it. Add that acting to it. It makes it more beautiful. But you can decide not to add it. In this material, it was not added. But it makes more sense when you put acting. So surface tension is a force acting per unit length. The unit of surface tension is Newton meter. Is it clear? The unit of surface tension is Newton meter. Is it clear to you? So that is that. Now we are going to be talking about the applications of the effects of surface tension. Applications of the effects of surface tension. Now this is where you are going to listen very well, because these are things that you do every day, but you don't know that you are actually the principles of surface tension. Now I'm going to talk about washing of clothes in the laundry. There's nobody that don't wash clothes. You wash clothes with soap. You wash clothes with detergents. Is it clear to you? Now, washing of clothes will not be possible if there was no surface tension. If there was no force that is called surface tension. Is it clear? Washing of clothes is made possible because of surface tension. Is it clear? Now, you know that your clothes, we call them fabrics or fiber. Now your clothes are referred to as fiber or fabrics. Whatever you are putting on, whether you are putting on a jean trouser, or you are putting on a cotton shirt, or you are putting on a silk material, or a gabardine or a polyester, whatever the material is. Once that material is dirty, then it need to be washed. Why the washing of those clothes with detergent on water is possible with surface tension. So I'm going to explain it to you for better understanding. Now, soaps and detergents lower the surface tension of water. Is it clear? This is desirable for cleaning purposes because the high surface tension of pure water prevent it from easily entering between the fiber of materials. I don't know if you are listening. Because the surface now, imagine just be washing clothes with ordinary water without soap. You will see that naturally it will not be pleasurable to you because the surface tension becomes very high. What we are saying is that water will not easily penetrate the pores of the cloth you are washing, the material you are washing, whatever, whether it is bed sheet, whether it is cap, so far it's a fiber, it's a garment, made up of any material, water will not easily enter because of the high surface tension of water. But when you pour detergent inside water, or you mix the water with soap, soap, all this key soap or whatever soap, then the surface tension of the water is reduced. When the surface tension of the water is reduced, it makes water to be able to enter inside the material easily. Is it clear to you? So it lowers the surface tension of water and makes the water to be able to enter easily. So soaps and detergents lower the surface tension of water. This is very needed in laundries when washing and for washing purposes, for cleaning purposes, because the high surface tension of water or pure water. What we mean by pure water is water that is not contaminated, water that they have not added soap to or detergent to. That is clean water, water you just fetch from the borehole, water that will just supply to you, you just fetch from your tap. That is pure water. Not we are not talking of when we say pure water as in seed water, that is in a sachet. No, I'm talking about water you just fetch pure from the tap, or that you fetch from water you fetch from a well, or water that you bought from Yes. Yes. I was trying to explain to you, apart from the practical application I've given to you, I'm also trying to tell you that high temperature decreases the surface tension of water. Is it clear? The higher the temperature of water, the lower the surface tension. Is it clear to you? The implication of that is that your washing will also be easier when the water you are using to wash is warm. I don't know if you got it right. Washing will become easier when the water you are using to wash is warm. So, because the higher the temperature of water, the lower the surface tension. So aside using a soap and detergent to lower the surface tension of water, then heat, that is temperature. Maybe you increase the temperature of water from 5 degrees Celsius, maybe from 2 degrees Celsius, 3 degrees Celsius to 20, 25 degrees Celsius. Then the surface tension is also going to reduce. Is it clear? So it makes washing better. So that is what I need to add to it. So it makes it effective to use hot water for cleaning. So hot water is better for cleaning than cold water. Why is it so? Because hot water reduces the surface tension of water. Also, washing with soaps and detergents makes washing to be easier because soaps and detergent also reduce the surface tension of water. We leave that point and we go to the next practical application of the effect of surface tension. No, here I will tell you about, now take down the material used in making umbrellas and raincoats. You know umbrella. Now it's raining now in the area, in the part of Lagos I reside. Now, if you want to go out while it is raining, then it is advisable that you go out with either a raincoat with a cap, or you carry your umbrella. That umbrella seems to be the easiest. Is it clear to you? Now, while you are inside the rain with an umbrella, you see that water cannot penetrate through the fibers of the material that they use in making the umbrella and start dropping on your body. Is it clear to you? Compared to when you are using other, maybe when you just put a cloth in your head, you just put another cloth in your head, you see that after some time, the water is going to percolate through the fabrics, or the fiber rather, the pores of the fabric, and start falling on you. Is it clear to you? So another practical application of the effect of surface tension is in the making of raincoats and umbrellas, and other waterproof objects. Now, these materials I've just given you: umbrellas, raincoats, and other waterproofs. You know waterproof, what they call nylons, all these nylons and etc. They tend to have a thin, that is all those materials I just told you now. They have what is called a thin film of water between each fibers. Now, due to surface tension, the trapped water molecules form an elastic skin and prevent further seepage of water through the fiber. Is it clear to you? I'm going to come again because it's a bit technical what I'm explaining to you, and it's good. I know you are going to understand it casually, as in normally, but the technical aspect is what matters. Is it clear? Because there's nobody that has not used umbrella before. You know that when you are using umbrella, water does not fall through the fabrics of the material they use in doing the umbrella and start following your body. Otherwise, umbrellas will be useless. The same thing, while you put on a raincoat, you see that the raincoat, only the surface will be wet. The water will not be able. The water will not be able to percolate through the raincoat and enter your clothes, the main clothes you are wearing. Is it clear to you? So why is it so? It is so because there is a thin film of water between the fibers of the raincoat or the umbrella or any waterproof material. Is it clear? What does it do? It's because this is so because of the surface tension between the water that is dropping from the sky and the material, the surface of the material of the raincoat or the umbrella. A surface tension increases, a surface tension emerge or comes to place between the water that is dropping on the material that is used to make the waterproof or that is used to make the raincoat or the umbrella. So as soon as the rain drops on the material, there is automatically a surface tension between the two substances, between the material and the water. What now happens is that a thin film is going to exist where the water is going to stay, thereby preventing water from percolating through the material. Is it clear to you? That is another practical explanation of surface tension. So we leave that aspect now. You are going to write down another subtopic. I'm going to be very fast so that we can meet up with time, because the material, what we have today is large, but I'm going to be fast so that we can meet up. Now you are going to write down another subtopic: adhesion and cohesion. Adhesion and cohesion. Adhesion and cohesion. Is it clear to you? You would have heard of, these things are not straight to anybody that passed through a science class in the secondary school. Is it clear? So these are forces of cohesion and adhesion. They are forces. Now these forces, they act independently. Is it clear? These forces come to play whether the forces are acting between the molecules of the same material or between the molecule of different materials. That is what determines whether we are dealing with the force of adhesion or cohesion. Is it clear? So now I'm going to define the two concepts, and I'm going to start talking about them. They're giving the practical application of these forces. Now, the force of attraction between molecules of the same substance is called cohesion. Please write down. The force of attraction between molecules of the same substance is called cohesion. While the force of attraction between molecules of different substances is called adhesion. I come again for the last time. The subtopic is adhesion and cohesion. I said the forces of attraction between molecules of the same substance is called cohesion, while the forces of attraction between molecules of different substances is called adhesion. Now, what does it mean is that even though water is a substance that is the same, there is a force of attraction that is holding the water molecules together that make it to be water. Is it clear? Now, all substances, is it mercury? Is it alcohol? Is it water, alcohol, mercury? These are the three liquids or substances that are mainly used when we are treating this topic of adhesion and cohesion. Is it clear to you? Now, these three substances now, there is a force of attraction between the molecules of the three substances because they are the same. Is it clear? So those forces are called cohesion. Now, when you now mix water and alcohol together, you know that there is a force that is going to hold the two substances together now. That force is now become adhesion. Is it clear? So it's very simple. I'm not going to dwell on it too much, but the practical aspect. So I start the explanation. I said adhesion of water to glass is stronger than the cohesion of water. Is it clear? Now, when you are able to pour water in a glass and to drink water from a glass, from a plastic cup, from an iron cup, or maybe a steel cup, or aluminum cup, or a brass cup, or a silver cup, or a golden cup, you are able to drink water from it because the forces of adhesion of water to the material with which the cup was made is high. Is it clear to you? Now, water is a different substance. The glass, that is the ceramic glass now, or the plastic cup, or the silver or gold cup, depending on your level, they are different substances. So there is going to be a force that is going to make the water to be able to stay put in that cup. Now, this force now is acting between two substances, the cup material and the water itself. If the force of adhesion is strong between the material and water will stay in the cup. Water is going to stay there and you'll be able to drink from it. Is it clear to you? Now, that same cup that you pour water on, go and pour mercury on it. Is it clear? You will see that mercury will not be able to stay in those materials. Even when you pour water on the table, water will stay on top of the table. When you pour water on a glass table, water will stay on top of the glass table until you clean it off. But go and put mercury on top of a glass table, or go and put mercury on a glass cup, or any other material for that matter. You will see that mercury, the force of adhesion of mercury to any material is very, very, very low. Is it clear? So for that reason, mercury will not be able to adhere to that material. It will be looking for a way of escape. Is it clear to you? So that is what we mean by adhesion. So the adhesion of water to glass is stronger than the cohesion of water. Is it clear? Hence, when water is spilled on a clean glass surface, it wets it. Is it clear? So water is able to wet glass because the force of adhesion of water to glass is high. Now, the application is not just that. What is now the application of this high adhesion force between water and glass? You see that in thermometers, water can be used. Is it clear? Although it's not popular, but it can be used. Is it clear? Now, that is one of the practical application. Then I'm going to give you more application as we progress. Now, then, apart from that, we are able to store water in glass materials and other materials for this same reason. Now, in contrast, the cohesion of mercury is greater than the adhesion to glass. Is it clear? That is, the forces that hold mercury together is very high. That is called the cohesion force, the force of attraction between the molecules of mercury is very high. So mercury is not able to adhere to other surfaces. It's not able to join to other surfaces because the forces that is holding the molecules together is high compared to the forces that is holding the molecules of water together. The cohesion of water is low. That is why it's able to adhere to glass surface, while the cohesion of mercury is very high. So the adhesion to surfaces is low. I don't know whether the logic is, you got the logic correctly. If you didn't get it correctly, I'm going to come again. But mind you, our time is fast spent and I have a lot of stuff to give you today. Now, I said the adhesion of water to glass is stronger than the cohesion of water itself, which means the forces of attraction that hold water together is lower compared to the forces that will hold the water to other surfaces. Whereas for mercury, the forces that are holding the molecules of mercury together is very high. So the cohesion of mercury is very high, thereby making the adhesion of mercury to surfaces very low. I leave that aspect. I now said, thus, when mercury is spilled on a glass, it forms small and spherical droplets or large flattened drops and does not wet glass. For the same reason, when these liquids are placed in a glass vessels, the water form a concave meniscus, while the mercury will form a convex meniscus. Is it clear to you? What I mean by concave is that it's going to come down. It's going to form something like a semicircle, like a half moon, but the inside is going to be facing up. Whereas mercury is going to form a convex meniscus, just like the windscreen of a car. Is it clear? It's going to form something like the windscreen of a car. You know, the windscreen of a car is a convex mirror, so it's going to form something like that because the cohesion of mercury is very high, while the adhesion to glass is very low. I think I have explained myself enough. So we are going to leave that as that subtopic and go to what is called capillarity. We go to capillarity. So write down capillarity. Write down capillarity. I'm going to be very fast because we have limited time. Capillarity is responsible for the rise of liquid in a narrow glass tube when placed in a container. Please, I'm going to quickly explain this one with a straw. There is nobody that has not taken mineral with a straw before. Nobody here that has not taken mineral or taken water with a straw before. And those plastic straws that they give to you when you buy mineral in a restaurant or in a bar, or drink anything at all, you say they should give you a straw. That is what we mean by a tube. Now, when you put that straw, when you put it inside a basin of water, maybe a glass, water is going to rise up through the internal diameter of the straw. Water is going to come up. Water is going to be coming up. You know these things. You can particularize it today. Go and look for two straws, and look for alcohol, and look for water, and look for mercury. You see that when you place the straw inside these three substances, they are going to have different meniscus. Is it clear? So capillarity is responsible for the rise of fluids or liquids in a narrow glass tube when placed in a container. Capillarity is defined as the tendency of liquids to rise or fall in a narrow capillary tubes. Is it clear? So whether the liquid is going to rise or fall depends on the cohesion and the adhesion forces that is acting between the molecules of those liquids. I believe you are following. Now, practical application of capillarity. Number one, the rising up of water up the stem of plants. When you plant crops in your farm or in your garden, you see that they take water through the roots of the plants, and the tap root and the fibrous root, and they act like a capillary tube. They take water and other minerals down, and they take it up the stem of the tree, and to sustain the tree, to provide water for photosynthesis. That is an example of the use of capillarity in nature. Then the ink in your biro, you can see that if you are there now, there's no student that is listening to me now that is not holding a biro. You see that if you remove that tube inside your biro, is actually a capillary tube, a plastic capillary tube. Is it clear to you? You can see that it's going to be holding ink, either blue ink or red ink or green ink, depending on the color of the ink. So that is also an example of capillarity. Then blood, then in the body, blood spread through the fine capillary channels of the body. The movement of blood around blood vessels is also a capillary action. Is it clear to you? Then liquid waxes that are moving up the wick of a candle. When you on a candle, it is the movement of wax up from the down to the top of the wick that makes your candle to burn. The same thing with lantern. Those of you that were using lantern in those days, when you put a wick in a lantern, it is capillary action that make kerosene to move up the wick of a lantern to give you light in all these bush lanterns. Is it clear? Those are examples of practical application of capillarity. Is it clear? Or capillary action. We leave that aspect now and quickly take the last topic, which is viscosity. We quickly take viscosity. If you are there, we quickly take viscosity. Viscosity is our last topic for today. It's part of what we have been talking about. I'll be talking about fluid at rest and in motion. So everything I'm telling you about is part of the topic, but I've subdivided into smaller and smaller subtopics. So viscosity, in a nutshell, the simplest definition of viscosity is the frictional forces in fluids. Please, you can write it down. That's my definition, and it's correct. The frictional force experienced in fluid, that is liquid and gases, is called viscosity. Although in some materials, they will tell you that the frictional force in gases is called drag. They are also correct, but viscosity supersedes drag. Is it clear? So the frictional force, by now you know the meaning of frictional force. That is the force that opposes motion. In fluid, that is in liquid and gases, that friction is called viscosity. That is the resistance to the free movement of substances, of materials through fluid, is called viscosity. Is it clear to you? Now, we also call the resistance to movement in gases as drag. Don't forget, we also call it drag. Therefore, for this reason, aircraft, balloon, when you inflate a balloon and release it, the balloon is going to experience a drag. Is it clear? It's going to experience a drag. Why aircraft, helicopters, and other bodies, other what is it called? Materials are flying in the air. All those things like aircraft and helicopters, they also experience what is called a drag. Is it clear? but the construction of an aircraft is such a way that the effect of drag is limited. Is it clear to you? So they are able to overcome drag with the construction of the wings of the aircraft and other features that are added. So the name given to the internal friction that exists between the layers of a liquid or gas in motion is viscosity. That is number one. The opposite force is known as drag. In liquids, the viscosity is due to the cohesive forces between liquid molecules. Please quickly take this down. In liquids, the viscosity is due to the cohesive forces between liquid molecules. Is it clear to you? Now you will understand it better if you know that the more the cohesive forces between the molecules of the liquid, the higher the viscosity. Is it clear to you? For that reason, red oil and water and engine oil and grease, when you put all of them together in different red containers and you put a pebble, a coin, put a coin inside, one naira coin, put them inside, one inside, and see the movement. The one of water will get to the bottom of the container easily because the cohesive forces between the molecules of water is low. While for other substances like engine oil, like red oil, like what is it called again? Grease, you see that the thing will take time. If you know, sometimes it may not even be possible for the coin to get to the bottom of the container because the cohesive forces between the molecules of those other substances is higher. Is it clear to you? Now, in gases, it is due to the collision of between molecules. Viscosity in gases is due to the collision between molecules. Is it clear? So, the more the collision of, now you know that the collision in gases, force collision increases when temperature increases. Is it clear to you? So when temperature increases, then what happens is that the high temperature makes collision to increase. When you heat gases, the collision between the molecules and the container that is holding them is going to increase. So that collision is going to prevent, it's going to make the viscosity to be high. So when you put substance in it, there is going to be resistance. So now the last but not the least is that viscosity increases with increasing temperature for gases and decreases with increasing temperature in liquids. I'm going to take this again. Viscosity, I've told you that, you know, by now you know the meaning of viscosity. Viscosity is the frictional forces or frictional force in liquids and gases. They also call the frictional force in gases drag. Is it clear? But for the purpose of this course, we are taking everything as viscosity, whether it is a frictional force in liquid or frictional force in gases. I'm taking everything together as one. Is it clear to you? So I'm now telling you that viscosity, that is the frictional force, increases with increasing temperature for gases. So when the temperature for gases is increasing, the viscosity will increase. Why is this so? Because the collision, the gases were going to be bumping to each other more because of high temperature. They are going to, you know this one in gas laws now. So with the increase, all those Charles law and Boyle's laws, this is what they are talking about. So when you increase the temperature of a gas, the rate of collision of the gas molecules is going to increase. When the rate of the collision increases, then the viscosity of the gas is going to increase. Is it clear to you? It's going to increase. Then for liquids, viscosity decreases with increasing temperature. Is it clear? Now imagine if red oil is, the temperature is if red oil is kept at 20 degrees Celsius and another red oil is kept at 2 degrees Celsius, all of them are red oil, or let me say 5 degrees Celsius, then put a coin inside the two red oil, you will see that the one at 20 degrees Celsius, the viscosity is going to be lower than the one at 5 degrees Celsius. Is it clear to you? So that shows that increasing temperature, that shows that increasing temperature, please I come again, decrease with that for liquids, increasing temperature decreases the viscosity. I believe you still got it right. I believe that there's no mix up there. I think that there was almost a mix up. I was explaining that of gases. I said viscosity increases with increasing temperature for gases, and decreases with increasing temperature in liquids. Is it clear? Which means when you increase the temperature of a liquid, it becomes lighter. When it becomes lighter, then the viscosity is going to be lower. So that is that. So please quickly take down your assignment before we summarize everything. Please take down your assignment for today. Number 1 assignment. Explain the mechanism behind drinking of water. Let me come again. Explain the mechanism behind the drinking of water or carbonated drinks using a straw. Assignment for today. Explain the mechanism behind the drinking of water or carbonated soft drinks, that is Coca-Cola, Fanta, 7-Up, using a straw. When you use a straw, explain the mechanism that is behind the use of straw. Why is it possible for you to be able to use your straw to drink from a bottle? Explain it. Number 2, differentiate between the forces of adhesion and cohesion with practical examples. Number two, differentiate between the forces of adhesion and cohesion with practical examples. Number 1, assignment. Explain the mechanism behind the drinking of water or carbonated soft drink using a straw. I believe you got the assignments, the 2 assignments. I've given you the 2 assignments. Okay, I'll give you the assignments. I'll give you the assignments. So I'm gonna come for the last time because I've not been logged out. So I said the assignment for today's topic, which is fluid at rest and emotion, is the number 1. I said explain the mechanism behind the drinking of water or carbonated soft drinks using a straw. What I'm telling you is that explain how we drink water with a straw, or how we drink water or soft drink like Coca-Cola with a straw. Many people like to drink their soft drink with a straw. What is the mechanism behind that drinking with a straw? Then number 2, I said differentiate between the forces of adhesion and cohesion with practical examples. That is the assignment for today. And I believe this ends the class. This is our last class for as far as this online classes is concerned. This is our 4th contact, and we are able to cover a lot of grounds in technical mechanisms, starting from Newton's law of motion, from Newton's law of universal gravity, from friction. We also talk about Archimedes' principles of flotation, that is shipping, etc. We talk about all of them. And today, I try to explain to you the science of fluid at rest and in motion. So I believe you people will be able to understand everything I explained to you. I explained what is surface tension. I explained what is I also explained the application of the effect of surface tension. I explained the forces of adhesion and cohesion. I explained capillarity. I explained viscosity. Those are all the topics I explained today. Time will not permit us to go to terminal velocity, but you are going to read out the other aspect on your own. So I think we have exhausted our time. This is 2 o'clock. We are supposed to start with another course now. That is a workshop on electrical machines. Thank you very much for your time. Do go through all these materials and answer the question I sent to the email. Thank you very much.